Good morning to everyone. I am Rohan Sutradhar and my team member is Prathama Sarkar. We have installed the essential Java library and importing crucial dependencies such as NumPy, Pandas, TensorFlow, and IPython. We have fetched the CSV file and WAV file from Kaggle. We have partitioned the WAV file and CSV file into two different paths, named it as metadata path and WAV path for our convenience. Now we are reading the CSV file with the help of pd.readCSV and looking the last 10 values with df.tail from the table. We are taking only two columns from the CSV file, giving the name as file name and normalized transcription. Here we are dividing the dataset into training and validation sets to facilitate effective model training. Here we are implementing pre-processing steps with a key emphasis on character mapping using the powerful keras.layers.stringlookup functionality. Here we create the function that describes the transformation that we apply to each element of our dataset. Now we are processing the audio. First we are reading the WAV file. Next decoding the WAV file. Then changing type to float. After that, to get the spectrogram we have done this. We only need the magnitude, so we will be applying tf.abs. Now doing normalization. After doing the audio processing, now we have to process the label, so first converting label to lowercase. Then splitting the label using tf.strings. Then we mapped the characters in label to numbers. Finally returning a dictionary as the model is expecting two inputs. We create a tf.data.dataset object that yields the transformed elements in the same order as they appeared in the input. Then considering a batch size of our choice and defining the training and validation dataset. Now let's visualize an example in our dataset, including the audio clip, the spectrogram and the corresponding label. We can now see the output as in the form of WAV file and spectrogram. Now defining the CTC loss function here. We now define our model. We will define a model similar to DeepSpeech 2. Craft a sophisticated model inspired by DeepSpeech 2, incorporating convolutional layer 1 and convolutional layer 2. Reshaping the resulted volume to feed the RNN's layers and hence creating RNN layers. Then creating dense layer and classification layer after that. Compiling and returning the model, then to get the model we write this line of code. Now in the output we are getting the layers shape. Getting total params to 6628480. Trainable params to 6628352. Non-trainable params 128 byte. In this step we are training and evaluating it and also using a callback class to output a few transcriptions during training. Now we are starting the training process by running 5 epoch in Google Colab. After running 5 epoch we are getting word error rate 0.6213. To run 5 epoch our system took 2 hours and 30 minutes. Now for more clarity we are checking results on more validation samples and getting the target and prediction like this. Since we are getting only 5 epoch in the Google Colab, so we have done further research how to run maximum number of epoch and got the solution that we can run maximum number of epoch in Kaggle because Kaggle provide P100 GPU for free. This is the first epoch. This is the second epoch. We are getting word error rate as 0.87. In the fifth epoch we are getting 0.61 word error rate. Let's move to 50th epoch. So, this is the 50 number of epoch. And the word error rate is 0.18. You can see the target and prediction. Let's see some more samples. Thank you for watching.